happening. Here we see an example of our parent function. So our parent function is f of x equals x, and we can see that on the graph here. Now, if we transformed this function, we would change the name of it because it is a new function, and we call it g of x. What transformation happened between f of x and g of x? Well, we multiplied by 2. But notice that the parentheses are around the x, so we are not grouping our 2 and x together. 2 is on the outside of x. This means that we are affecting a change in y. Remember, f of x and g of x are simply y. We call them by different names, so we can discuss the two of them at the same time and not mix them up. So this change of times 2 is affecting all of our y values for our g of x function. But first, let's start with listing out the x and y values of our f of x function, or the parent function. We could choose some values. I'm going to do -2. I'm going to do 0 and 1. So if we're talking about coordinate points here, with my f of x function, I would find that if I plugged in -2 for x, I would get back in return y equaling, or my f of x equaling -2. If I plugged in 0 for my f of x, I would get back 0 for my y. If I plugged in 1 for my x, I would get back f of x equals 1, or y equals 1. This makes sense since this is the simplest type of function we could have, f of x equaling x. We plugged in each of our x values for x, and we get back our y value, which are the same. If we plotted these coordinate points, we would see them over here. We have -2, -2, -2, -2 right here. We have 0, 0 right here, and we have 1, 1 right here. There's just 3 coordinate points out of an infinite number that we could have plotted. So now we're going to do the same thing. We're going to find our x and y coordinate points, but we're going to find them for our transformed function. So what I'm going to do is I'm going to write out another part of my table here. And we're going to find out what happens when we multiply 2 times our f of x on the outside. What happens to each of our y values? So this is our transformed function that we're talking about. If we take our g of x function and we account for the times 2, but we replace each of the x values with the ones that we chose, so -2, we could find out what our y value results in. So g of x equals 2 times -2, which would give us g of x equals -4. So this would become -4. Then when we have g of x equals 2 times 0, you get g of x equals 0, because 2 times 0 is 0. If we had g of x equals 2 times 1, you would get g of x equals 2. Now, if we wanted to find our new coordinate points for the new function g of x, all we have to do is take our original x coordinates and pair them up with our new y coordinates. And that would look like this. X and g of x, we're going to say. The reason we're talking about g of x instead of just writing y is because these are the new function values, new coordinate points. So these coordinates would be -2, 0, and 1. And then we use our g of x values, so -4, 0, and 2. We can plot these coordinate points starting with -2, -4, -2, -4 would be right here. Then we see 0, 0 in the same place. Then we have 1, 2 in the next spot. So over 1, up 2, right here. We can see where our points changed. Our 0, 0 origin stayed in the same spot, but the other 2 points navigated down and the other one navigated upwards. What we do, or what we call this when we see this happening, is a vertical stretch of the parent function, so a vertical stretch. So if you think about, if I had my hand here on this point of my function, and we know it's infinite, but if we were to just grab it in those 2 spots, and we started stretching this vertically, we started pulling on it in this direction and pulling on it in this direction, we would start to take shape for our purple function. That's why we call it just simply a vertical stretch. So we're pulling it towards the y-axis, stretching both of the ends. And that is a vertical stretch or vertical dilation.